Good afternoon, everybody. Thank you for joining us on BBI's webinar about bioplastics. My name is David Newman. I'm the Managing Director of the Bio-Based and Biodegradable Industries Association, sitting here in London. And I'm very honoured to be joined by three of our members who are joint panellists with me, Dr. John Williams, who is Director of Aquapakpolymers and S'Investec Investment Company, Andy Williams, Marketing Manager for Middle East and North America, I believe, of Futamura, who are a company in Cumbria making biomaterial packaging. Andy will tell us more about that. And Julia Schifter from TIPA in Israel, also another company making biomaterial packaging. Welcome to all three of you. The way in which we will handle this webinar today is that I will introduce each of the three speakers and they will then talk for roughly about 10-12 minutes. John Williams talking about bioplastics, Andy talking about the uses of biomaterials, and Julia looking at some of the questions around infrastructure and market potential. And then once those introductory statements have been made, then I will open the floor to you all for your questions. Now, you can type your questions in on your right-hand column on the page. You can type in your questions, or you can wait, and I will try to connect you so that you can voice your questions at the end of the session. In the background, our colleague Charles Newman, who is no relation to me whatsoever, is holding the technological fort. So he will ensure that the whole thing runs smoothly, and I thank you very much for setting this up. So, John, we have 62 participants listening, connected in. Welcome to them all. I'm going to hand you the floor, John, for 10-12 minutes, and I'm going to ask you, firstly, maybe you'd like to give the audience a little bit of background of where you come from and experience in the bioplastics industry, and then tell us what do you think bioplastics are, what bioplastics can do, and some of the perceptions and misconceptions around them.
Thank you, David. Good afternoon, everyone, and good afternoon, fellow panelists. Yeah, I come from, if you like, what is perceived to be the dark side. So I started in petroplastics for around 15 years with Total and Henkel. And then as part of that process of development, we started working on what was then bio-based materials and bio-based plastics. And I ended up sort of morphing into that industry, and I was actually head of the National Non-Food Crop Centre's materials side, which was the government's arm's length body in this area for about 7 years or so, before going into the investment side, specifically looking at targets in this area to invest in, and one of those targets was Aquapakpolymers, where I'm currently directly involved as technical director. So I've sort of seen all ends of this in terms of development, certifications, regulation, the challenges, the scale up, etc. So I'm hoping I can sort of put a little bit of an explanation around where bio-based has come from and what it's about. So I'm just going to attempt to share my screen here, hopefully. So I hope everybody can see that. So we'll just go back, actually.
Yes, we can see that, John. I just want to confirm.
What I think some people get confused at, and I mean, I know there are a number in the audience that aren't going to be confused in this, but some people do get confused. And I think it's important we keep reminding everybody what this is about. You know, bioplastics are plastics, just like petroplastics. The source of the carbon in the plastic chain, which is predominantly the content of the material, is the key. Bioplastics are derived from non-fossil resources of carbon. So that's predominantly can be things like biomass or spent agricultural waste or agricultural crops, sugars, starches, algae. So you basically anything which is a non-petrocarbons, or non-natural gas, non-crude oil, you can derive a bioplastic from depending on the process. Now, I think where the confusion sometimes comes from is that there's an assumption by many that bioplastics are therefore automatically biodegradable. The two things are entirely different. What we can think of is that there are equally petroplastics can be biodegradable as well as non-biodegradable. Bioplastics are exactly the same. The end of life, or the route to its breakdown in natural environment, is completely dependent on its chemical form, not its derivation of carbon. So what you'll see from the chart there is you'll see in terms of fossil-based and bio-based, you can see equally you have some conventional plastics like polyethylenes, polypropylenes, polyethylene terephthalates, PET, which are chemical platforms from crude oil in this case, which are non-biodegradable. And you have also then some material from petromaterials like polycaprolactone, for example, which is, again, it's derived from a crude oil or a refinery operation, but is biodegradable. And similarly with bioplastics, we can manufacture, and in fact do manufacture across the world, bio-based polyethylene. That polyethylene is exactly the same in terms of its functional, chemical, physical performance as the petromaterial. And similarly, there are now routes to some of the others. So polyamides, which obviously go on towards nylons, and polyethylene terephthalate. So there are bio-based versions or routes to that. So in those terms, it's important, I think, to remember that the chemical function itself is exactly the same. The molecular structure of that material is exactly the same. The carbon just simply comes from a different source. It comes from a bio source and not a petro source. Now, if we switch to the side which is biodegradable, then we are looking at materials which are things like polylactic acid, polybutylene adipates, starches, for example, which are inherently biodegradable. We'll come to what that term means in a moment. But similarly, there are petroplastics which do the same thing. So it's important that to get that difference, I think, straight in everybody's mind, that if we want to produce material which is exactly the same as we see now from our petro sources, we can do, or we can alternatively make something slightly different. In some cases, that's advantageous. So what we have when we start looking at how these things break down in the environment or in controlled conditions such as composting, is we clearly need to put some definition to that. And over the last 10 or 15 years or so, standardization testing regimes are coming to place across the world to give, in some cases, national, in other cases, regional, geographical harmonized norms for understanding what that actual definition means. So biodegradable on its own doesn't particularly mean anything other than it will break down eventually in some environmental criteria. That could be marine, it could be freshwater, it could be soil, it could be simply lying around as litter. It can be in landfill, it can be in a controlled environment like composting or anaerobic digestion. So so it's a general explanation of how something biodegrades. So obviously lots of things biodegrade. We do in the end, if you leave us long enough, once we're done. But what's important is if you're going to actually trying to develop in a circular economy type scenario where you're looking for end of life to be part of the function of the primary material once you've used it, then you need to actually have harmonized and defined norms and test standards so everybody's actually on the same page, claiming the same things, and the material is tested in the same way. Hence the reason, for example, some of the things that I mentioned there, EN 13432, which is the European harmonized norm for compostability of packaging. EN 14995 is the equivalent test for plastics in general. Now, there are a number of side technologies, if you like, spurious technologies, I think, as we would call them in the BBIA, oxo-degradables being one of them, where the driver towards trying to deal with plastic waste has led to a number of claims which are unsubstantiated, that's for sure, in terms of third-party approval. So, for example, the addition of an additive which allegedly promotes biodegradation in things like polyolefins, whether that's a biopolyolefin or a petro one. that is an example of one where, you know, time and time again, this keeps coming up. And if you look at the evidence, if you look at lots of third-party investigation of research into this, and also much practical evidence in the field, these systems simply don't work. And from a chemical point of view, I guess it's unsurprising. Do they improve it, you know, increase the fragmentation rates of polymer chains? Yes, they do. Do they increase the biodegradation rate? No, they don't. So we've got to be really careful, and that's why these harmonized norms, etc., are really important. And also picking the right materials is exactly the right thing to do in terms of a primary purpose, and then as well in combination with a primary purpose, how does that actually fit in an end-of-life scenario? One of the other myths around bioplastics is recyclability. There is a tendency to think that conventional and usually petro materials are magically recyclable, where bioplastics, for some bizarre reason, are seen not to be. It's simply not true. Now, there's a technical route to recycling, and then there's an economic value argument for recycling. So technically, you can recycle probably anything, practically, almost, but economically, clearly, you're not going to do that for all sorts of reasons: energy costs, collection mechanisms, form of material, recovery of material back to some other form, which is actually a viable material. So there's a number of questions here, but there's absolutely no reason, if you are comparing apples with apples, like with like, for example, that if you are taking a petro PE and a bio PE, both of those materials, if they're in a suitable form, can be recycled if they can be collected in a suitable volume. That's probably pretty much simple mechanical separation and recycling. We can go on to more complicated recycling in terms of, you know, actually stripping out the chemistry. So, for example, PLA, polylactic acid, if you can collect enough of it, can be chemically recycled back into lactic acid, and that lactic acid can then go on to be repolymerized ultimately to PLA. This is clearly a growing situation in terms of, particularly now, in terms of the noise around plastics in general, as to there's a little bit of catch-up probably needs to be done in terms of infrastructure for recycling collections, and also implementation of technology in an economic and sensible way. But this is not to do whether one is petro and whether one is bio. It is a question of what the form of the plastic material is. And in some cases, bioplastics can give you an advantage towards it, in terms of if you choose the right things, for example, in food waste collections, and they go into composting and anaerobic digestion much more efficiently, then that is an efficient way of recovering, or at least dealing with that material rather than the way it's dealt with at the moment. So that's you know, there's a number of things around that, and I think mainstream we're kind of getting that message across now. It's getting there, but it's taken a little bit of time to do that. So finally, I think I'll just cover a little bit on a verification. It is clearly as the penetration and scale up of bio-based plastics continues to increase. Some of those will be used on their own. Some of those will be used in combination with petro materials, because ultimately you want primary functionality in your product. You don't want to lose that, but you want to take perhaps a transitional step towards a sustainable and renewable based content. So you need to measure that content, and one way of doing that is to measure the type of carbon that is in the polymer itself. And there are a number of methods of doing that, but one of the common methods is to measure the carbon-14. There is an American test method of doing that, which is D6866, and that is, I think, being taken up by most of the rest of the world globally in terms of a relatively easy test to at least determine you have renewable carbon versus petrocarbon, and therefore the content. I've mentioned the compostability standards, EN 13432, the European one, increasingly used elsewhere, particularly in Asia, as basically the standard to follow for industrial compostability of packaging, and similar standards for compostability of plastics in general. there are others. USA has ASTM D6400. Japanese have their own, and there are increasingly harmonized norms around this. And of course, the other question is that's directly collected industrial compostability. There's always a question around, could you do this in a home situation, in terms of home compostability? That's a little bit more challenging, both in terms of understanding what materials go in there. So there's a labeling question around things like that. And also you are slightly restricted, as inevitably on the control of that and temperatures within those home composting situations. So there is a home composting voluntary standard and test methods for doing this to again, the purpose being that if you're claiming that everybody's claiming the same thing against the same test method. So I think that's just to round up is say, you know, bio-based plastics can equally be the same as petro-based plastics in terms of their chemical form, but you can also develop different materials that are difficult to produce from petro routes, which give you different functionality. So you're actually widening the plastic family, if you like, in terms of its performance. And then of course you have different options. At the end of the day, it's renewable carbon in the chain. So renewable carbon is less damaging in terms of GHGs and climate change effects than non-renewable carbon. So that's one of the drivers. So I'm going to stop my my screen share and hand back to David.
Thank you, John. Thanks very much for that. Just a quick question. It gets thrown at me a hell of a lot. Oh, it's very confusing. There are many types of bioplastics. And my response to that is, well, why is it so confusing? There are many types of plastic as well. And maybe you could just say a word or two of that about how big the plastics family is.
Well, I think plastics, you know, with all the current noise, it's sometimes, and all the negative current noise, I think, there's a lot of things being spoken about plastics. But if you look at the history of plastics, it certainly go back to the latter half of the 19th century, and really in terms of volume production from about the 1930s onwards, as we refined oil better, particularly. Plastics are, you know, fantastic functional materials. They are the most successful materials I think we've ever developed as global technologists, if you like. You know, that if you look at the applications where these things can be used and are being used, is it surprising that inevitably we have a fairly complex structure in comparison to simpler materials like metals and glass, for example, where you are restricted on what functionalities you can give. So bioplastics are no different. You know, bioplastics, as I've said, offer in some cases routes to polymers which are difficult to get from petro materials, and therefore you're actually widening that. So yeah, I understand why people get confused, but we use materials for functionality as a starter for 10.
Thank you, John. Now I'm going to ask you, John, if you would mute your microphone. I'll pass over to Andy. Thank you. And I'll come back to you, John, when there are questions from our listeners. Andy, welcome. Introduce yourself, please, and your experience in biomaterials and their use. And I'm going to ask you if you would talk for 10 minutes or so, please, about how you see biomaterials working in the UK, particularly in and around packaging.
Thank you, David. Just a quick one. Can you just confirm you can see my screen okay?
Yes, I can.
Perfect. Okay. Thank you. Good afternoon, everybody. Yes, I'm scared to say that I'm just about celebrating my 30th year in the flexible packaging industry this year. And all through that time, I've been involved in both conventional petro-based plastic films as well as cellulose-based materials. That all changed in 2016 when Futamura took over the cellulose activities of my previous employer, Innovia. And since that time, we've been focused 100% on. I'm going to focus this particular presentation on what I would say are the 5 or 6 subject areas which we get questioned most about from customers looking to make a move into more sustainable forms of packaging. And the first of those, well, well, are they actually relevant? I think John's already mentioned the difference in scale between conventional plastics and biomaterials. And so you could, I think if you measured it on a graph, you'd say that they're barely registering today, less than 1% of the overall plastics packaging industry. But actually, they're very much the products of the moment, and there's very, very good reasons why. We know in the UK, the government announced its environmental plan in January of this year, and that focused very much on plastics reduction. There's huge media coverage these days of the plastics issue, the negative effects caused by the misuse and mishandling of plastics. And we're starting to see calls for so-called plastic-free solutions. And I'll talk about that a little bit later on. For the packaging technologist in me struggles with the term, but as a consumer, I get it. It's a term that is easy to understand. We're not all packaging technologists. In fact, 99.99% of us are not packaging technologists. So we have to be able to use a language which resonates with consumers as well. My own business area has always been lightweight, flexible plastics, which are great for minimizing resource. But actually, the flip side to that is they're almost impossible to recycle. And what most consumers won't realize is that a huge percentage of flexible packaging is actually a laminate of 2, 3, or more layers, all done for very, very good technical reasons to give excellent product protection characteristics, but bringing real difficulties in terms of the potential availability and practicality of being able to recycle those materials after use. The other thing that's, I think, very, very important is actually the scale of the waste problem. Now, I've put up there on the slide a little breakdown of England's waste management profile, local authority waste management, but actually that works for the whole of the UK, and it tends to work for the whole of Europe and pretty much everywhere else in the globe as well. It's roughly the same proportions. And here we are talking about the plastics issue, which is less than 10% of the kind of waste which local authorities have to deal with. And if you look at that, food waste is nearly 17%, garden waste nearly 17%. There are other wastes as well, which are organic, putrescible wastes. So actually, the biggest issue in the waste management pile is organic waste of various types that we need to be trying to get value back. And that organic waste is a problem at the moment, but what we should be looking at is seeing it as a potential asset, because if we can manage that kind of material more effectively, we can create an energy source and we can create a soil improvement opportunity out of that material. And one of the key aspects that we'll see coming up is that one of the big aims of these materials is to help to divert that organic waste away from landfill and towards a much more beneficial end of life. Where do these materials fit best? If you remember in John's slide, he talked about materials which were bio-based but not designed to be specifically compostable. Top left-hand corner there, you see the iconic Coca-Cola bottle. And if many of you have been looking at it, it's now made from up to 30% plant-based sources. It's still a polyester. It still goes through the polyester recycling system, but it's a bio-based, a naturally derived polyester rather than a fossil-derived one. Taking a few other highlights, here we see compostable films being used to line food waste caddies, specifically designed to do what I was mentioning earlier, which is take food waste from the homes and take it off towards organic recycling methods such as anaerobic digestion or composting. For the retailers in the audience, the third and fourth items on the top there are both retailer-led projects. The third one is bio tea, so organic tea from DM drugstores in Germany, the leading German retailer, switching out of conventional plastic films and into NatureFlex as part of their sustainability program. And the far right there are products from the Ecoplaza store, which we'll talk about a little bit later on, the first so-called plastic-free aisle coming into retailers. Highlighted in the middle here, we have T-Pigs. That is a compostable tea bag inside a compostable film wrapper. And I believe T-Pigs is the first UK company to achieve the plastic-free mark just very recently. We have sandwich skillets, which are using compostable films to replace the plastic films which are lined to the cardboard. This is for food service applications where everything is in a closed loop environment, and these materials will be taken back together with the food waste and composted. Moving on, we have potato chips, a very interesting application in terms of its technical performance. Historically, biomaterials were thought of as being essentially permeable materials, not suitable for dry foods, but foods don't come much drier than potato chips. It's a great example of how the technology has moved on today with biodegradable and compostable materials. A couple of other applications, a very nice one down here is Percol capsules for Nespresso type machines. These, when they're not Nespresso, are often done in conventional plastics, and increasingly we're seeing a lot of these now move over to bioplastics. And when you think about it, they are containing spent coffee. So you've got a mixed material there, and it's a very great idea to be able to put those into compostable materials so that all of that waste can go off and create, help to create valuable compost. I mentioned technical performance, and I realize that many in the audience won't be necessarily packaging technologists, but just to give you a quick flavor here, I've taken one of our materials, Natureflex NK, and just given it a couple of comparisons to its nearest conventional plastic film. What you can see there in terms of haze or clarity, very, very similar. Same thing in terms of gloss characteristics. If we're talking about maximum use temperatures, maybe for ovenable type applications or reheating applications, you see that Natureflex again has the heat resistance that you would associate with a polyester film today. So in terms of functional properties, they are improving all of the time. In terms of barrier, what we're looking at here for high barrier properties is to be down as low as possible towards that number 1, bottom left-hand corner on the graph. And you can see that the Natureflex NK product there already has actually a better gas barrier than most conventional plastics, and a particularly good moisture barrier as well. So we're starting to see, if I can call it that, conventional packaging performance, but derived from renewable and compostable packaging materials. There's a lot of hype around this whole concept of the plastic-free aisle, and as I mentioned before, the packaging technologist in me struggles with it a little bit, but I get what they're trying to achieve here. The people behind the plastic-free aisle are not anti-packaging. They actually understand the value of packaging. What they're looking to do is move packaging on to the next stage. And ironically, I think the plastic-free aisle has a number of advantages, even for the conventional packaging industry. What are they? Well, first of all, what we're seeing here is a practical showcase. It shows the circularity of these materials. They come from renewable resources. They're used for packaging applications, and they go back to nature afterwards. So they're following the natural carbon cycle. But they're also creating a product showcase. So by having them on display in one place, your consumers are able to see what's happening in terms of these developments. They're seeing that this is practical. Other companies are seeing it's practical, so they'll start to adopt. And in many ways, it's a bit like having the gluten-free aisle or the organic produce aisle. It's that kind of concept. Another very important aspect, biomaterials are more expensive than conventional plastics. So how do you get them moving forward when there's a cost penalty? Well, the plastic-free aisle creates a level playing field here. If you work for company A, you know that company B has got to be using the same type of materials in order to qualify to go on display on that aisle. So you're on a cost neutral basis on that particular aspect. So that can help companies to stop thinking, I can't move because my competitor will. You can move together on this and make a difference. Very important too is that as we start to have more commercial increased sales, what do sales generate? Increased investment, increased R&D, increased reasons to develop the products in terms of performance, more entrants come into the whole marketplace. And very importantly for us here locally in the UK and Europe, is that actually we'll see the raw materials being manufactured and converted here. So we'll see more jobs created locally compared to the situation with many other materials which may be sourced via very, very low cost countries, very, very far away from our shores. One absolutely critical final point, I was asked yesterday actually, if all the plastic needed to be compostable tomorrow, could we cope? The honest answer is no, the supply chain couldn't cope. What we need here is an evolution towards these materials in a controlled way. We don't want an absolute revolution. We need to be able to transition in a controlled way that allows industry to match that and doesn't do what could happen, which is create additional food waste by reducing the amount of critical packaging which is used to transport food safely to market. So that evolution, not revolution, is a message that I think is very, very important and very beneficial with this particular concept. Just to show what that might mean then, we start off with the manufacture of the raw materials. You can see there the plastic-free aisle in the stores in Ecoplaza in Amsterdam. A close-up there of some of the compostable packaging. We design it to look like conventional plastics, but they're compostable. After it's done its packaging job, put it into the food caddy with the residual food waste. That will then go off, depending on the local infrastructure, to technologies such as industrial composting or biogas generation via anaerobic digestion. That then is ultimately used to improve soil, fertilize the soil, but also improve the structure of soil, which is then what allows you to grow further crops, and so the cycle continues. And that's what we mean by the circularity of these particular materials. Okay, what's the payback for brands and retailers? Because at the end of the day, if the brands and the retailers don't adopt it, nothing moves forward. Well, I've just taken a couple of examples here from feedback from some of our customers and their experiences when they've moved from the conventional plastic towards our type of materials. So we've had an organic tea customer who's seen a 64% increase in sales when they switched, and a confectionery customer who actually ran an exercise with their customer base saying, are you composting these materials at home? Do they work? And so on. And they had an excellent set of feedback from their customers. A number of them saying, we didn't believe it was going to work, but it absolutely did. They disappeared within 5 or 6 weeks. It's very impressive. So they really do compost as is proven by the test methods that we all test and adhere to. It's an opportunity for positive PR. I think we're in a situation today where many companies are trying to hide the fact that they use packaging at all because plastics are coming under such pressure. And so it gives brands who are operating in the ethical space the opportunity to actually talk very proudly about what they're doing in terms of their package. I think it's also important that as major brands start to make a move, they use their websites in order to get good messages out to the customers about why they're doing it in certain places and why they're not necessarily able to do it everywhere just yet. So we have today the advantage of social media, the internet and everything. We can actually manage the message effectively to those people who are most keen to find out more about what's going on. And the big gap that we have today in terms of plastics recycling, with the real difficulties we have, particularly in flexibles and the lack of recycling of such materials, is that we have the opportunity to actually talk very proudly about what to do with our materials after use. And we're starting to see a number of countries, and I've taken France, the Netherlands and India as examples of that, where governments are starting to legislate in favor of compostable materials for particular market sectors. So for example, in India already, all tobacco packaging is supposed to be in compostable materials. In France, already all carrier bags in stores and fresh produce bags have to be home compostable materials. And by 2021, all of their food service catering type packaging will also have to be in these type of materials as well. Nice thing of what they're doing in France is that they're announcing this legislation with an implementation date 3 or 4 years later. That gives industry the time to react. It gives the converters time to find the right type of materials to convert them into high performance packaging. It's not an immediate law. It's a law with a time scale which allows you to get all the ducks in a row and move forward in a practical way. And to finish up then, I'm often asked what's the future going to look like in terms of these materials? And 3 or 4 things I'd highlight. First thing, very important, sometimes this is portrayed as sort of biomaterials coming along and being the enemies of plastics, and I don't see that at all. I mean, as John's very first words were how important plastic is to our society today, and we need to make a transition. We need to have good solutions to replace them if we're going to move forward. And in many areas, conventional plastics may be the best answer, but certainly in other areas, bioplastics and biomaterials are very, very interesting. What will happen in terms of the feedstocks? I think you'll see that more and more the feedstocks for these materials will be the kind of agricultural wastes that are created. So as the food industry supplies food to the public, it creates agricultural wastes, and we'll see them more and more being the feedstocks that we work with in order to deliver the packaging solutions. Also, I think it's important to say to people that technology is progressing all the time. So if you tried out compostable materials 5 or 6 years ago and you found the functional performance wasn't there, I would suggest you try again, because the technology is moving on at a light speed. It really is, in terms of the barrier performance, transparency, heat resistance, sealability, and so on. So try and try again. I think you'll also see a much wider profile in terms of biodegradation. When we started working on this, it was all about industrial composting. Then people were realizing home composting was important in certain areas. Now, of course, we've got a big focus on marine. None of us here are trying to say that these materials are the way to solve the marine plastics issue. But having said that, there are some applications where situations where it's going to happen. And I think you'll see our industry doing more and more work on the whole subject of marine biodegradation as well going forward, as the standards evolve and we know what we're trying to test to. And so, yeah, we need wider adoption of these materials. It's moving fast. It's moving faster still since the massive increase in focus on this that started off in the UK market, particularly with the Blue Planet program in the autumn of last year. Watch the technical progress develop. Consumer demand is already growing. And I think if we were to fast forward many hundreds of years, you might actually have a situation where you look on the fossil fuel age as actually being something of a blip. You know, for many, many hundreds of years, we used renewable raw materials, and we used them because they were the resources open to us. And from about 1800 on until today, we discovered oil and started using what you could derive from oil. I think in generations to come, when the oil age is over, everyone will just be thinking, well, that was just a little blip. We're now doing it again. We're creating the plastics of the future, the functional materials of the future, but we're doing it with feedstocks that we can renew and reuse as much as possible. Thank you.
Thank you, Andy. I've got several questions from the audience, but just before passing on to Julia, there's one specific one which I would like to ask you. Can you hear me?
Go ahead.
Yeah, you can hear me. Okay.
Yeah.
From our friend Jose Louis in Vancouver, he's asking, well, why would you combine plastic windows with cardboard boxes on sandwiches and make them both uncyclable? Unrecyclable.
Yeah, I mean, there is a massive amount of applications where plastics get associated with paper and board. It's done for functional reasons. I mean, the customer, when he wants to buy his sandwiches in that particular example, wants to see what they look like, what's the flavor I'm going to buy, what are the ingredients. And so you get that combination of the requirement to actually see the product and also give it good barrier properties with the structural requirement of having a cardboard container to deliver it. That example was sandwiches, but you see it as well with many, many cardboard box applications, frozen foods through to chocolate boxes and so on, whiskey cartons. It's a hugely diverse application, that kind of association of plastics with paper materials.
Yeah, okay. Good, thank you, Andy. We'll come back to you with other questions, and I've got questions for you too, John, from the audience. But meanwhile, let me pass over the microphone to Julia Schifter, who is from TIPA in Israel. Welcome, Julia. Also a new member of BBIA, and welcome to the family. Julia, while you speak, I'm going to be getting up and moving because I see my battery's about to crash on me, so I need to go back to my room and plug in. So please don't think I've left you, but I'm going to be moving around for a couple of minutes. Julia, I'd like you, if you would, to talk about the recycling facilities for compostable materials that there are in the UK, and also, given your international and privileged international view of markets, where you think markets are going and how you see these developing over the next few years. Thank you.
Thank you, David. Hi, everyone, and good afternoon. Thanks for joining us. I'll start by maybe saying a little bit about myself, about TIPA. I've been with the company for 6 years, working on bioplastics. Let me just give you just 1 second to share the screen. Can you all see the screen well? David, can you see the screen?
Hi, Julia, it's Charles here. David's not here at the moment. I can't see the screen shared yet.
You can.
No, I can't see it either.
Oops, sorry about that. Let me just do this. Can you see it now?
That's great.
Sorry about that.
Okay.
I'll like David said, I'll give a bit of an overview of what's happening in terms of regulation and the market. We see a dramatic change as of the beginning of 2019 in terms of how plastic is being perceived. And then I'll talk a little bit about the opportunities and the challenges for the bioplastic industry. So I think we are all understand that plastic has really enabled us to live the convenient life we do today. It's very hard to imagine life today without plastics. Having said that, we've reached the point that we are probably producing way more plastic than we can ever absorb on planet. There's one particularly striking statistic says that over 50% of the plastic ever produced in the world was produced only in the last 15 years. It gives you a way to think of how plastic has been so available and used everywhere. One of the great challenges of plastic, even though everybody likes to brag about recycling and the recycling industry, the reality is that less than 9% of plastic that was ever recycled has been recycled. This is mainly due to economic challenges, but not only that, sometimes there are even technical challenges. All the flexibles that you see in this picture, for example, are usually blending different materials together. Therefore, technically, we don't have a technology today to separate the layers and get an economic value out of plastics. Moreover, we've realized that a lot of plastic is now is leaking into the sea, and we are heading into probably an environmental calamity if we continue to use plastics and discard plastics as we do today. One other dramatic thing that happened as of the beginning of this year is that China has actually decided to stop imports of plastics from the world. That has created a tremendous pressure on mostly the Western world, the UK being one of the countries kind of heavily affected by this, but also the US and Japan, where now plastic cannot anymore be shipped every day in containers into China, but needs to be handled locally. And naturally, the next thing that happened is, like you all probably know, and I guess most of you are based in the UK, Theresa May came up with this statement in which plastic has been addressed, and the plastic pact that has been now created in the UK is really trying to work on finding solutions to end this plastic epidemic, in a sense, where there's a very specific goal to reach to a point that by 2025, all plastic packaging would be either usable, recyclable, or compostable. And when we say compostable, we really mean when technically packages are still very important to preserve food or whatever goods they're packaging, and for many reasons they are not recyclable. Therefore, the next best venue would probably be composting those. A little bit of what happening is also happening in the European level. This is also some regulation that came up in January, or general statements where the EU wants to go. One of the things that the EU is working on now is developing a list of products and applications where they think biodegradable plastics should be the best alternative to conventional plastic. Another important factor that European Union is working on is actual proper labeling. Today, we don't have a unified labeling, and there are just some voluntary labels. I think both John and Andy showcase in their presentation some of these labels, but they're all voluntary labels, and we need a unified language to educate consumers what to do with biodegradable plastics. And associating biodegradable plastics is always is going to be part of organic waste. By 2025, there's going to be a ban on incinerating biodegradable waste. Hopefully more and more will be composted by then. And there's going to be a ban on landfilling biodegradable waste by 2030. So all that means that we're going to see much more infrastructure in the US to process food waste, and that should be accompanied also with biodegradable packaging waste. Some other individual countries are moving forward with these statements. Australia just came out with a statement that they're going to use also or move into all plastic packaging being reusable, recyclable, or compostable by 2025. This is quite recent. Canada is now looking into launching the same program. And in France, as I'm sure a lot of you are aware of, in 2017, a ban on certain applications, plastic application has been created, and now different packaging solutions need to be transferred from conventional plastic to compostable. The Netherlands, I think, is historically one of the most advanced countries in Europe, where tax reductions for compostable packaging has been around for many years. And in a sense, we see a thriving market in the Netherlands for many years for compostables, partially also because of the government taking a role in encouraging these solutions to be out there in the market. India is another, I mean, Asia, in a sense, is considered to be the next biggest consumer of bioplastics and compostables in particular. The European Union is the largest consumer, but this is probably going to shift to India in terms of volumes. There are several states that already started to ban uses of plastic packaging in different formats. And the government has announced that by 2020, they want to abolish any use of single-use plastics. So this is all in the making, and as the presentation kind of shows, I think we all understand that we live in a transitional moment in which countries, industry, and consumers understand that we've reached a tipping point in terms of the uses of plastics, and everybody is now looking to define how can they move away or move beyond plastics and to use more ecologically friendly solutions. This is the work that is done by the Ellen MacArthur Foundation that are convincing basically global brands to sign this statement that by 2025 they'll have 100% reusable, recyclable, or compostable plastics. You can see PepsiCo, Unilever, Walmart, Coca-Cola have signed up to this. Danone just signed, I think, last month or so. So it seems that all the global brands now take this responsibility quite seriously. In the UK, all of the major retailers have already announced that they're going to use the same recyclable, reusable, compostable packaging by 2022 to 2025. And there seems to, some of them seem to be wanting to move much faster than that, than the public statements. And like Andy mentioned, the opportunity for plastic-free aisles is one major outlet to start using compostable packaging in aisles that will be dedicated to alternative materials, and where cost could be helpful in terms of launching your products in our novel materials or in the biomaterials. And finally, we want to address the challenges, because as any new technology erupts, some challenges come along it. One of the challenges is the infrastructure. We already have some countries in Europe, like the Netherlands and Italy and France, in where organic waste is collected along bioplastic or compostable packaging solutions. We're in the UK, we're not there yet. But one of the things that the Plastic Pact is working on is exactly that, assuring that compostable packaging can be part of the organic waste stream. The good news for us as an industry is you actually don't have to add another waste bin to the collection system. The bins are already there. We're going to see much more of them because of the EU legislation banning either landfilling or incineration of organic waste. And then the natural route for compostable packaging would be via this organic waste bin. The International Solid Waste Association has published a couple of years ago a paper which supports the usage of compostable packaging within or incorporating these packages within organic waste. And like I said, this is already proven as effective in countries like Italy and the Netherlands. In the UK specifically, we have 53 composting plants, and they're all certified to accept compostable packaging. Many of them already do by some individual efforts, by some companies like Vegware or like the Co-op. And I think probably David will be able to elaborate on that. The second challenge, which you're probably all quite aware of, is obviously the price. Like any new technology, compostable or bioplastic or biomaterials cost more than conventional plastic. Today, the bioplastic industry, as Andy mentioned, is merely 1% of conventional plastic, and it's the chicken in the egg in terms of economies of scale. But what we see is that there's already over 60 countries that have placed either bans or heavy levies on flexible. Therefore, these countries are trying to do is actually reflect the real cost of using plastics to society. So either coming from regulation, we expect that compostable materials or biomaterials would be at par with conventional plastic, adding the tax that may occur, or a ban like it is in France, for example, or the plastic-free aisles, which is a more voluntary action. But again, this is where you could be at cost par with other competitors on that shelf. And that's about it for my part.
Thank you very much, Julia. I hope I'm back online. Yes, I am. There's a lot of questions coming, and I'm going to fire them out and ask you, each of you panelists, to pick them up. I think, firstly, John, there's the first set of questions really all sort of revolve around the issue of, isn't it misleading to use the term bioplastic? Shouldn't we be saying biodegradable plastic? Aren't people confused between home composting and industrial composting? How are we going to roll these materials out if only 2% of the population actually do home compost? The other series of questions which I'd ask you to look at here is the Tesco statement, which has created some, as you can imagine, some considerable interest, saying that they do not want to use industrial compostable materials in their packaging in the near future. So I'm going to throw those two questions out at you, John, and then I'm going to come back to Andy and to Julia for some others.
Okay. I just before I start, I think that I would like to hear Andy's views on the Tesco question. So I'll just sort of deal with the first part at the beginning. I think what everybody's got to bear in mind here is that the development of these new materials that just happen to be bio-based, for the reasons that Andy's done on his timeline, has created the question of not only whether you want obviously you need a primary function, but the driver over the last 10, 20 years or so has been towards, yeah, okay, but that's for primary function is fine. What do we do with the end of life or the end of its use? So bioplastics development over the last certainly 10 or 15 years certainly has, at the same time as developing technology which produces a user-ready primary functional material, in some cases with better functionality than the historic plastics that it's been replacing, has also been developing and answering the questions about what you do with the material and what our options are at the end of life. Inevitably, if you look at the development of normal plastics, and not through anybody's fault, it's just simply the way we dealt with materials early on, is the plastics were developed simply for a primary use. Nobody in the 1940s and 50s was particularly caring about what happened to these things, or any material for that matter, at its end of life. So these considerations were never given. So complex materials without any particular route to an end of life were developed because they were very good and functionally very good at what they do. Now, unfortunately, historically for those materials, it's very difficult to suddenly rewind the clock. and develop economic and technological routes to dealing with those materials. So in some respects, bioplastics has a slight advantage in the fact that we've absorbed and learnt everything that's been done on the petropolymer chain, and at the same time considered the circular economy and end-of-life approach as to what these things functionally can do. Now, so you've got that aspect. You've also then got an aspect that the waste industry, generally speaking, or the handling of waste generally across the world, and certainly in Western Europe as an initial thing, was simply get rid of this material as quickly and as cheaply as you possibly can. We don't want any value out of this. We just want to get rid of it, hence landfill and hence incineration. Now, we're, of course, clearly now in the mode of, no, we can't do that. That's not the right thing to do. We need to maximize resources, and we need to get as much out of these materials as we possibly can, which means we don't incinerate blindly and we don't landfill. Therefore, we need other options. So the waste industry has and is continuing to adopt technologies and operating methods to try and become not waste logistic handlers, but waste refiners. And in order to increase the value in that waste refining mechanism, and that could be composting, it could be anaerobic digestion, it can be technical recycling. There are a number of options here. It could be repulping. All these sort of things come into play. It becomes, source separation becomes key. The technologies to source separate become key. And more importantly, sometimes you hit a brick wall because simply the material you're dealing with won't fit easily any of those options. So change the material. And often that change of material drives you towards a bio route. So if I may, I'd like to pass the Tesco question over to Andy. I'm sorry to pass the ball on you, but you're much more familiar with the retail end than I am.
Yeah, I think, thank you, John. Yes, there is, Andy, because the question also coming from Laura from Marks and Spencer's is, well, said this, but also is PA really compatible with compost? Traditional two questions to test the position and the position around PLA recycling.
Right. Okay. Actually, David, you were breaking up at my end with the question there. What was the question about PLA? Okay, I'll try and answer what I can. Hopefully you can hear me all right. I think that was a curveball question, John. Thank you for that. It's difficult for me to sort of comment about one retailer specifically. What I would say, I think we have to take a little bit of context of what's happened just in the last few months. Suddenly, following Blue Planet and government statements and so on, this has taken on a massive level of sort of media interest that it didn't have before. Even though biomaterials were moving strongly forward, it's suddenly just gone to a whole different level. And I think it's fair to say that many brands and retailers have been going through oh my God, we have to get a bit of a statement together very, very quickly, and haven't necessarily had the time and the information to form their long-term view. So I think you might see some short-term views that will evolve over the course of the next few months. What could I say beyond that? Why would you put on the do not use list the materials which are from readily renewable resources, which then have a perfectly good functional role that can equal the performance of conventional plastics in many areas, and then give you all of the biodegradation ability, including potentially in future marine biodegradability? You cannot believe that's a long-term position. So I think there's some short-term confusion, and I understand that because everything has happened so very, very quickly. People need to get their heads around it. In a previous answer, I said our own position is to be aligned with the recommendations of the Ellen MacArthur Foundation, which is to make sure that all materials are reusable, recyclable, or compostable by 2025. And I would imagine that most retailers will follow that type of approach once they've got all their thinking in place. I can see we're all muted at the moment. Have we got another question to take?
Hi there, Andy. It's Charles here. I just thought I'd sort of start to address some of the questions that we've got still left in the Q&A, if you're able to see the Q&A panel. Laura Fernandez has asked, what is the industry doing to inform and educate its customers?
Okay, the best thing from our point of view is to work with the BBIA, because that gives us an industry voice rather than just an individual company voice. We are trying to act as much as possible in accordance with the other key stakeholders by engaging with the likes of RAP, BPF, OPRL, and so on, in order to get some of these particular subjects into place. So I know that BBIA was meeting with RAP yesterday. There are more discussions coming on. So engagement with all of the stakeholders is the key way forward on this, to actually make progress in dealing with some of the roadblocks to further progress.
Okay, could we open up to any of the others? John, Julia, would you like to kind of address that question, what the industry is doing to inform and educate customers?
Yeah, I mean, this is clearly an ongoing situation, as Andy said. You know, certainly we at the BBIA are working with everybody. This is about getting as much information in a coordinated way as possible, and obviously seeing everybody's point of view as clearly, as long as that doesn't provide too much of a blockage to moving forward. I think there has been many. Inevitably, as new materials enter an existing marketplace, there has been some misclaims and misdirections of material in the early days. But I think we're long past that now in terms of where the direction of travel. I think what's important is that you know, we don't start sort of carte blanche trying to solve the problem by just defaulting back to old materials and banning the new ones, because that's part of the issue. And I think that understanding and that, you know, I think, I mean, if you look at, you know, not being, you know, we're all average consumers, and you know, fortunately we're in the business, so we kind of understand what's going on. But most people who go shopping, you know, look at a packaging item in the supermarket, they don't understand the complexity of that item. And I think part of that education process is that it's that complexity of that material delivering whatever it is that you're purchasing is often there for, you know, a very, very good reason. And once that's been explained, then you can actually start to unwind and explain as to why, therefore, it is actually difficult to deal with some of these things. These are the options that are available. These are the new materials that are coming along that are going to at least start to solve that issue. And I think it's just about that joined up thinking. You know, circular economy, Ellen MacArthur, that's the big picture. As always, the devil's in the detail, and that's what we've got to get to grips with.
Can you hear me now?
Yes.
Okay. A series of questions about compost facilities. Maybe, Julia, I would ask you to address this. People are asking whether actually compost facilities exist. You say 53, and people are saying they didn't know that, and whether they really do want to take and will effectively compost these materials. One writer says, is it true that they will incinerate the bioplastics and consider bioplastics a pollutant to food waste composting, which shows the level of sort of understanding we have about what composting facilities are. Julia, would you like to talk about that for a minute or two?
Yeah, I think part of the challenge for everybody is that there's a new reality which didn't exist before, in which compostable materials are designed to be processed in compost facilities. This is happening worldwide in many places in the world where a lot of, let's say, single-use serviceware is being composted along with food waste. And there are actually studies that even showcase that, for example, in countries where there's a legislation requires you to throw all your organic waste in a compostable bag, more people were recycling their home kitchen waste than before. So there are a lot of benefits into actually putting compostable materials along the food waste in these bins, but a greater industry effort needs to take place in order for all of these things to happen. Because the standards are the ones that validate the materials can be processed in these facilities. Studies show that this happens and is actually beneficial and would add more compost to our fertilizer as the end product for these infrastructure sites. But more than just industry have to worry that these things happen. It's a whole stakeholders position in which governments and local councils in the UK and infrastructure and industry are all pulling their hands together in order to make this happen. At the moment in the UK, some local councils allow for compostable bags to be discarded along the other kitchen waste bin. But this is not widely across the UK. And I think part of what the BBI is doing in the Plastic Pact is to assure that this is going to become a valid way to discard compostable packaging. One of the things that we are always kind of accused is that compostable packaging actually need to be treated. Yeah, they were not designed ever to be discarded or thrown out of your window and forget about. Compostable packaging need to be collected and recycled just like any other plastic waste, just in their own stream and not in the conventional stream.
Yes, correct. There's a misapprehension that if you've got compostable packaging right out the window and it will disappear into the environment naturally, whereas it needs to be composted in a time and place. Coming to the end of the questions, there's a couple of questions around the use of the competition between growing crops for food and growing crops for making bioplastics. And were we to turn all the plastics in the world to bioplastics, then we'll run out of space to grow food on. And there are some very good statistics there on our website. They're on our questions and answer page on our website, which show where we are today. Maybe John or Andy, you've come across these questions presumably all the time in your conversations. You'd like to just say a few words. Maybe John first.
Yeah, it's an understandable question, you know, given the question about sustainability of feedstock, you know, versus our normal ones. And I think if you look at the number of studies over the years by highly credible third-party people, the conclusion is that, generally speaking, if you move even first-generation agricultural crops towards a biomaterial, the impact on the food chain is minimal. You are less than, much less than 1% of the land area crop yield in doing that. I think people sometimes forget that north of 40% of sugar production has always gone on food applications. Greater than 40% of starch production has always gone into food applications. If we start considering those sort of options in terms of, we only grow nutritional materials in our land areas, then in that case we need to stop growing tea, coffee, and tobacco. There's all sorts of nuance to that, but the truth is, if you look at the numbers, if you just direct it towards a material chain, then the stats are fine. The stress on the system is absolutely minimal. Not so if you start including things like biofuels and bioenergy. That's a different ball game, and that's sometimes where it gets mixed up.
I think people forget that 70% of all land area in Europe is actually used for animals, either growing food for animals or for grazing animals. That gives you the proportion. Andy, did you want to add anything to that?
Yeah, I mean, I think John, and you've just said the essential things there. I made a point in my last slide about where industry is going. So, in a way, this industry is a toddler. It's starting to walk, and it's really growing and improving in capability and so on. But it's not where it will be in the future. And the big changes in future I will see is that increasingly it'll be things like agricultural wastes, which are the feedstocks for many of these materials. So although the overall picture is of like food versus packaging, if you like, is much less worrying than people's immediate reactions. And certainly I would address people towards the BBIA website and also the European Bioplastics website, both of which have excellent information in terms of the food question. But I think what you'll kind of see, if I can put it this way, is we'll grow plants to create food, and the fruit of the plant will be what gives what feeds people. But then the other parts of the plant will be for soil improvement, for structural improvement, and for other applications, including industrial and packaging applications. So if you grow some corn, we'll use the corn for food, and we use the stalks and the leaves and everything else for the other uses.
And I think that the holy grail, of course, is to use as much agricultural waste as we possibly can, and even food waste, if we possibly can, take the sugars and starches from them to make bioplastics a third or fourth generation of bioplastics. And I know a lot of research is going into that at the moment. Julia, I have a last question, and I'm going to throw at you. The worst question of the day, of course, because it's the last one. And we are asked, well, Joe Foster asks, is the cost difference between compostables and conventional flexible packaging a real barrier? Will people actually, consumers, want to pay the extra cost for compostables? Or is it simply for very small niche, high value items?
So, well, there are different ways to look at this question. First of all, studies conducted by Nielsen, for example, repeatedly year by year, say that people are looking for more sustainable packaging solutions and will actually pay more. This specifically goes to the millennial generation that is keen to living in a world where sustainability is better treated by packaging. So, but there's always, okay, how can a company really move forward with a mass commodity product using a compostables? And I think Andy touched upon this by saying this is an evolution. As much as our industry wants to be able to transform as many packaging solutions which are not recyclable for different reasons into compostables, for example, I think we've reached a point that end consumers are so aware of the negative impacts of plastics that, in a sense, it's probably, we live in a time where on a brand level and image, it's probably more beneficial for brands to start using compostables on different applications than not using those. The Coca-Cola story, I think, is a great one, in which Coca-Cola decided to move to their PET-based bottles, and this has been quite effective for them. So I think it's a journey that companies, we see a lot of it at TIPA. Companies are really wanting to start this journey and are really asking what would be the first kind of line of products that they would want to move to compostables. So, you know, if you're a company that sells a zillion tons of flexible packaging, for example, you would probably want to start with products that would best resonate with alternative packaging and move forward from there to your more mainstream kind of products.
Thank you, Julia and Andy. Are there any last comments that you wish to make before I wrap up?
Is that for me? I'm sorry.
For all three of you. Any last comments you wish to make?
I think just a quick.
A lot of people are addressing the composting, the infrastructure in the UK, maybe David, you can elaborate a little bit on what can practically be done today?
Yeah, just briefly on this, for those who've asked questions about, Jane Gilbert is online and she's a composting expert and former chair of the Composting Association here in the UK. The composting facilities in the UK, 53 sites, are certified to take animal byproducts, which means they can also take packaging contaminated with food waste. A lot of them are reluctant to do that, let's be fair, and they're reluctant to do that because they are getting so much non-compostable plastic coming in with their food waste. They are wary about taking more packaging, and they have difficulty in distinguish compostable from non-compostable packaging. So we have a very big problem in terms of dirty food waste collection schemes bringing plastics to composting facilities. But the composting facilities are there, they're spread across the country. There's not enough of them. We need that to be increased. But as food waste collections become mandatory under EU law, and we hope under UK law in the next 2 or 3 years, are sure that there will be an increase in the uptake of those materials and the treatment of them. As regards anaerobic digestion, there are anaerobic digestion plants that also compost their digestate post-process. There are also dry anaerobic digestion plants which compost the materials and therefore can recover the value of the compostable materials in them. Having said that, the UK is still very, very far behind some of the countries which you cited, Julia. We are treating about 10% of our food waste here and throwing over almost 7 million tons of food waste to landfill and to incineration, which is the real scandal, not the fact that the compost facilities are not handling it enough, the fact that we're actually not collecting it and we're getting rid of all those resources in a very unsustainable way. There's a couple of questions that people have asked. The slides, yes, they will be available online probably from tomorrow. This presentation, this webinar, you can see it again. If anybody has specific questions which have not been answered, they can send an email through the website. Yes, Ian Schofield, please come to the next BBI meeting. You'll be more than welcome. But there are meetings for members and there are meetings for the public, and we will be having, after the summer, another public meeting here in London. And of course, anybody who's interested in this whole world of compostable or bio-based materials, and not just packaging, but also around other materials, is welcome to join the association and join in our campaigning for more sustainable materials in the economy. Andy, Julia, any last comments from you? Otherwise, I will close the meeting.
No, that's fine for me. Thank you very much.
Okay. Well, let me thank the three of you, Andy, Julia, and John. Let me thank Charles Newman for setting this up. We've had over 100 participants participate through the course of the webinar, which was far beyond our expectations. Thank you all for having taken part, and I hope that we've all learned something from it. Goodbye, everybody.
Thank you very much. Thank you.
Thank you.